Hello. So this week we don't have the YouTube video lectures, but we're going to focus on algorithms. And I want to explain how that program that I gave you in the homework, how does it work? It has lots of new instructions. So I want to go slowly through all of those instructions and explain how it implements bubble sort. All right, so here's the homework. I'm going to focus on part B. And in particular, I'm going to focus here on the second part of part B, which is this program that you can just copy and paste into the computing machine and run it yourself. And what this program does, it sorts four numbers in memory using bubble sort. Okay, so that everybody kind of has an idea for. Man, forgot the numbers. Okay, 5 to 10, 5, 6, 3, 9, 4. All right, it's just a refresher of how bubble sort works. Okay, it's important that you understand how bubble sort works to understand how that program works. So just as a refresher, bubble sort works with many passes, I'm calling them sweeps. Okay, it sweeps the numbers many times, multiple times. How many times? Well, potentially 8 times. Okay, so because in this case, because it's 8 numbers. If it was 4 numbers, it's 4 times. So it potentially sweeps the number of numbers times. All right. So let's start with the first sweep. First sweep, we're going to compare the first 2 numbers. Now we check if the one on the left is greater than the one on the right, then we swap them. That's the case. All right. When we're done on this comparison, we're going to move on. We're going to compare the numbers at location 1 with the number at location 2. In this case, the one on the left is smaller, so we don't swap. All right. And we move on. We're going to compare the number at location 2 with the number at location 3. In this case, 10 is greater than 5, so we swap. All right. And we move on. We're going to compare the number at location 3 with the number at location 4. In this case, 10 is greater than 6, so we swap. We move on. We're going to compare the number at location 4 with the number at location 5. In this case, 10 is greater, we swap. We're going to compare next the number at location 5 with the number at location 6. With 10 is greater, then we swap. And finally, we compare the number at from location 6 with the number at location 7. And again, 10 is bigger, so we swap. We're done with the first sweep. All right, but we're not done sorting the numbers. We're going to have to do this again, another 7 times in this case, right? So we go back to the beginning and we compare again. So I'm going to stop here because it takes a long time. But basically, at every time that we make a new sweep, we're going to identify, this algorithm is going to identify the largest number that is still unsorted, and it's going to bubble it up to its position. So the first sweep identifies the largest number. The second sweep is going to identify the number 9 is going to switch it, to the right. And at every time it swaps numbers that are bigger than their left side neighbors. That's basically how bubble sort works, okay? So having said that, let's go here into the computing machine and analyze this code that I gave you in the homework. And before that, there's a lot of new instructions in here that I'm using that I haven't explained before, and that's the reason why I wanted to do this video. But before I even explain, just let me give you sort of the map of this code, okay? I'm going to use the memory for bubble sort. I'm going to use the memory in many different ways. So the first, the memory location 0 to 3, and the memory is this panel on the left, okay? Memory location 0 is the one on top, and then number 1, number 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. Okay, there's 16 memory locations from 0 to 15. And so I'm going to use memory location 0 to 3, so 0, 1, 2, 3, to hold the numbers. So these are going to hold the numbers to be sorted, okay? Memory location 15 I'm going to use it to count down the number of sweeps. Okay, something in here needs to know which sweep am I on, right? So that information is going to be on memory location 15. And finally, I'm going to use the registers R1 and R2 to hold values that correspond to memory locations of the two numbers that we're comparing every time. Okay, so hold, and I'll explain how this works, but basically R1 and R2 hold memory values that represent memory locations of the numbers to be compared. So how does it work? Okay, the first line is the new instruction is random for, and random for fills out the first four positions of memory with random numbers. Okay, that's a new instruction over here. I have the instruction setting here. So random, it's here, fills out memory location 0 through range -1 with random numbers. That's what happened over here. These are now our numbers to be sorted. As you can see, they are not sorted. And they are going to be sorted now, in the visualization, they were being sorted from left to right. So the biggest one is going to be on the right and the smallest on the left. In here, I'm going to sort them from bottom to up. So basically the largest one will be on top and the smallest one will be on the bottom of these four locations. Okay, so that's how we're going to do it. So let's sort this. So what I'm going to do, I'm going to put something on in location 15 to remember which sweep am I on. Okay, so we start at 3 and then we go to 2, then we go to 1, and then we go to 0 basically. So we're going to, in order to put something in memory, I have to put it first into a register. So I'm setting the register 0 with 3, and then I'm going to store that value in the register 0 in memory. All right, there it is now, down here, memory 15. So store is a new operation in here that you can see. So it stores the value of the register reg in memory location address. That's what happened over here. Okay, so now I'm going to set things up so that I'm going to start comparing the number at location 4 with the number at location 3, and then I'll compare the number at location 3 with the number of location 2, and then I compare the number, 3 and 2, 2, 1, and then 1 and 0. Those are the comparisons that I'm going to make, okay? So if I want to compare these two, the 3 and 2, I'm going to put 3 and 2 into 2 registers, okay? There they are. And now I'm going to use this new operation, compare, which is quite a sophisticated, complicated operation that I'm going to explain. It compares, it takes two registers, okay? It interprets the values of these registers as memory locations, okay? And it's going to compare the numbers at those memory locations. Let me explain here how to read this. So compare, without the star, it would compare directly to memory location, to memory locations, okay? But we're going to use this in an indirect manner. We're going to be using registers for a reason that I explain later. So we're going to compare, to put the addresses of the memory in these registers, and I'm going to compare star the values through these registers. And now what happens in the comparison, 3 things can happen. Either the first value is greater than the second value, or the second value is greater than the first value, or they're the same. Right? Those are the 3 things that happen when you compare 2 numbers. So when the first value is greater than the second, then I leave a signal in register R0, all right? In that case, when the first one is greater than the second one, R0 is set to 0. If the second one is greater than the first one, then R0 is set to 1. And if they're equal, R0 is set to 2. So after a comparison, we need to look into register 0 to see what happened, okay? So that's exactly what is going to compare these 2 numbers, memory locations 2 and 3, all right? In this case, 3 is So is R1 is 2 and 3. So R1 is greater than R2, I'm sorry, R1 is greater than R2. R1 has memory location 2 and R2 has memory location 3. So the first operator is greater, which means that it should be a 0 on register 0, okay? In here, we should be in this situation. Let's see. So we compare. Indeed, it's a 0, right? So it's a 0 means that the first one is bigger. In that case, we are going to leave them alone. We're not going to swap because we want the lower numbers at the bottom and the bigger numbers at the top. So in this case, we don't need to swap because 4,813 is already smaller than 5,962. So in this case, we're going to jump if 0, R0 to line 9, which is indeed R0 is 0. So we're going to jump to line 9. All right. So what do we do next? We're going to decrement these two registers so that we then compare memory location 2 with memory location 1. Okay, so we're going to decrement R1, we're going to decrement R2, and now we're going to basically repeat the comparison again. We're going to jump, in this case, R2 is still not 0. We'll need to stop eventually, but it's not 0, so we're going to go back again to comparing the numbers, okay? So we go back, we're going to compare the number at location 1 with the number at location 2. That's what's going on in here. So we're comparing 5,056 with 5,962. In this case, the second one is bigger. So that means that R1 is going to get a 1. Yeah, there you go. So now we're going to check what happened to R0. In this case, it's not 0. So it means that we're not going to jump. We're going to swap the numbers. So we're going to go, we're going to the next instruction. We're going to swap the numbers pointed to by these registers. So we're going to swap the numbers at location 1 and location 2. There, they swapped. Did you see? So swap is a new operation also here that you can check what it does. So the swap without star swaps when you give them addresses directly, and the swap with a star takes registers and interprets the values in those registers as memory locations and swaps the values at those memory locations, which is what happened over here. So we swapped one, we're ready to decrement. We're ready to decrement so that we can compare the value at location 1 with the value at location 0. Right? So we decrement, and we look into R2. If we got 0, it's not 0, so we still have one more comparison to make. So we go and make a comparison again. Okay, so now we're going to compare the number at location 0 with the number at location 1, right? That's the values over here. And again, the second one is bigger. Okay, so that means that R0 is going to be 1, indeed. And so we're not going to jump, we're going to swap. We're going to swap these two numbers. Yeah, so there you go. We swapped, and now the biggest number of them all is bubbled up, literally. It's down here. And now we're going to decrement R1 and decrement, there's no negative numbers in this machine, remember. So when decrement, it goes back to the next number after 0. It is in a circle, so it rolls back. And we decrement R2, but R2 is the one that we're going to check if it's a 0. So it's a 0. So we're not going to go back to line 6. We're going to continue to line 12. So now we're done with one sweep. Okay. Now we're going to do the next sweep. So that means that we're going to go get the number that we had in location 15. Okay, we put it back on register 0 in this case. We're going to decrement it because we made one sweep, we're ready to the next one. So we're going to say 2. And we're going to check, are we done, right? Did we reach 0? In this case, no, we did not reach 0. So if we didn't reach 0, then we are going to jump back to this line over here, line number 3, which is the sweep loop, in which we're going to store this new value back into memory 15. Okay, there you go, so that we can remember next time when we go and get it. And we're going to do another sweep, basically. Going to do it again. We're going to start at comparing the numbers at location 2 and 3, right? So set this in, we're going to compare them. In this case, no, the one, the one at location 3 is smaller, so we leave them alone. We decrement, we go back. We're not done yet in this sweep. We go back, we compare the numbers at location 1 with the number at location 2, and in this case, we're going to swap because 2 is bigger, right? So we're going to compare them. And indeed, there was a 1 in R2. So we're going to swap these two numbers at location 1 and location 2. Okay, there they're swapped. We decrement again. We go back. There's still one more comparison. So we compare the number at location 0 with the number at location 1. In this case, the first one is bigger, so we leave them alone, right? So we don't swap. So we decrement, and now R0 is 0. So that means that we are done with the second sweep. We're going to get the sweep counter in location 15. There it is on register 2. We're going to decrement it. And are we done yet? No, we're not done yet. So we still go back another sweep, right? And again, what do we start by doing? We start by putting this new value of the sweep counter back in memory 15, and we do it again. So we compare 2 and 3. In this case, 3 is bigger, so we're going to swap. There it is. These two swapped. We decrement the memory locations. It's not 0. We have to compare more. So we're going to compare now memory location 1 and 2. And in this case, we should leave them alone because one is bigger. Indeed, it's a 0. So we don't swap. We decrement again. We go back one last comparison. We're going to compare the number at location 0 with the number location 1. In this case, again, we should leave them alone. Okay. It's a 0 on the register 0. We don't swap. We decrement, and now R0 is 0. So that means we're done with the sweep, right? We go fetch 15 again. It's a 1. We decrement, and in this case now we're done, right? Because we decremented one time, and it's a 0, right? So we're not going to break another sweep. We've done all the sweeps that we needed to do, and indeed the numbers are sorted, as you can see here. The numbers are sorted. The largest one is on top. So in this case, we don't jump back to the sweep. We're done, and now the last part of this algorithm is it's going to print out the numbers on the on the display at the bottom, sorted one by one. So and it's sorted from the smallest to the largest. So it's going to set R2. So we have to print 4 numbers, right? So that's why this 4 comes. It's 4 numbers. We decrement it already. We fetch. Okay, fetch is a new operation also, which is it fetches some memory location into some register. But what does it mean? It means that it fetches the number that is given on the memory location that is in R2, and it puts it in R0. Well, let me show you fetch. So the fetch without star is very simple. So it fetches some direct address, and puts the value in the register. The fetch with the star does the same thing, but now the memory location is given in the register, right? So you put the memory location in a register, and you're going to get that memory location and put it in register 2. So what we're going to do here is register 2 is memory location number 3, which means that we're going to get this number 1474 and put it in register 0. All right, there. And now we're going to write register 0. And now we check if the counter of numbers is 0. In this case, not 0. So we go get another one, right? We decrement R2. We fetch again, it's the memory location 2, this one. We write it out. We go get one more, decrement. We fetch, that's number 1. We write it out. It's still not 0, so we do one more time. We decrement R2. We fetch memory location. We write it out. And now R2 is 0, so that means that we should stop, right? That's it. We're done, okay? So this is how this program works. There's basically 2 loops, all right? So there's an inner loop, and that's what I call an inner loop, which is that it's the thing that's going to compare 2 numbers, right? Every time. And then there's an outer loop that is the one that is performing that. So it's the sweeps. It's like, how many times do we sweep the numbers? Well, potentially we have to sweep them n times when n is the number of numbers that we need to sort. All right. So I just wanted to go explain, these instructions carefully. What you need to do for your homework is, so this is sorting 4 numbers. You need to change the algorithm so that it sorts 12 numbers. That should be super easy. Okay, that should be super easy. And then what you may need to think a little bit more is how to actually write it in pseudocode, right? Once you have this idea, you can start by doing this program, understand the program, and write it in pseudocode. And I am going to show you a lot more examples of pseudocode algorithms on Wednesday. So you may want to wait until then, or you can read ahead into the slides. I will explain a little bit more what kind of notation I would like you to use, okay? So that's it. I will see you on Wednesday.